So in this video, we'll be discussing about small signal tuned amplifier. So how does a small signal amplifier looks that you can see from the figure? A small signal amplifier is the one that consists of only one tank circuit. Its tank circuit is nothing but you have one resistance, inductance, capacitance that is being connected, that you can see from the very well you can see from the figure, and it helps us in amplifying range as it is determined by it. Okay, the tank circuit has a complete control what is the range of frequency that should be amplified. Okay, so by giving signal to its input terminal of various frequencies, the tank circuit on the collector delivers high impedance on the resonance frequency and thus helps in amplifying signal that is available at the output terminal actually. Okay, so this is a basic working of this particular tank circuit. So if you see the figure that you have a transistor that is being connected to the signal for an amplifying purpose, and you can see the input signals other than the resonant frequency that the tank circuit provides, that is again lower in impedance. Hence most of the signal is getting attenuated at the collector signal. For our reference, I have given the pin configuration over the slide. Next, I will be discussing how do we perform the analysis of the particular model, and what is the bandwidth determination that we'll be using on. So in any circuit analysis, so we have to draw their equivalent circuit of the amplifier, so which is drawn or shown over here. You can see the equivalent circuit of a single tone amplifier, and we have two assumptions on RL, load resistance, and one more on RDD dash. So with that, like initially we'll be performing the calculation for admittance y1 and y2. With the value of admittance, what we'll be doing is that we'll be calculating the current gain AI from the equation from the 3.2.4 that you can see from the slides. Once we calculate this current gain, and from that we'll be calculating what is the maximum gain that is being obtained in the circuit, and for that we have an equation that AI max that is equal to minus Gm into R. And once we have this information on maximum gain, so we'll be calculating the bandwidth determination, and for a bandwidth determination we have an equation that is equal to GMR, that is divided by square root of 2, and performing this calculation will get the bandwidth of this single tuned amplifier as 1 by 2 pi into RC. So why this particularly a 3 dB point is considered is that, like, it is a point at which a signal can be attenuated. So this is generally considered as a point for determining the filter bandwidth. That is why, like, all the discussion on equivalent circuit, which will be focusing on the next slide, next videos, will be using this 3 dB frequency point as a bandwidth determination point, and the bandwidth is defined as a difference between the upper and the lower 3 dB points in all the discussion as well. Okay, so with that we'll end up this single tuned amplifier. Thank you.